So I want to welcome everyone to January 2025 and our first meeting of the Houston Functional Programming User Group for the new year. As is now our tradition, we have Eric Normand speaking to us. This, we believe, is the fourth time he has spoken to our group. And he now always speaks in January. We do this because it is really, really cold where he is in Wisconsin and not as cold here. And so, we like to harass him a little bit about that. Um, so I will turn things over to Eric. Eric, welcome. It's really good to have you back.
Hello, thank you. It's good to be back. I really enjoy this tradition. When Claude invited me for this time, I was like, yes. I tend to use this as a way to work through ideas that I'm working on for my book. So this is the third year I'm talking about domain modeling, and every time I learn something, it's a good group, and I don't have to go outside for it because it is very cold. Um, I could just stay in a warm house. So I always do get envious when I see people in t-shirts. Luckily, I don't see a lot of t-shirts today because it's colder down there right now, but uh it's very cold here, just so you know. And it's good to see you. Thank you for having me. This is a great group. I really enjoy this. Should I start my presentation? I'll share
Yes, yes, this is your time.
my time. All right. Y'all can see that?
Yep, looks good.
Okay.
Yep.
So this is called Two and a Half More Domain Modeling Lenses. Like I said, I've given two other talks on the domain modeling um, is topic. About a year ago after, no, I guess it was 2 years ago. After giving a talk here, I decided to organize everything into lenses because the way I was talking about it at that time in this group, people wanted it to be, or they thought they were interpreting it as me giving a process. And I was not giving a process. That was the furthest thing from my mind. It's not what I wanted to do. Well, let's get into it. We'll talk more about that and what the lenses are. Oh, sorry, I gotta click over here. All right. Before we get into that, people mentioned my book, so I quickly threw up this slide. Um, this is a book about functional programming. It's for beginners because I felt like there wasn't a book out there that I could recommend to beginners. Everything was uh, too advanced, basically. They assumed you knew too much. This one starts very at the beginning with pure functions and what they are and why we do them. We spend maybe 4 or 5 chapters just on pure functions and immutable data. So check it out. This first link is gonna take you to Amazon. So if you like Amazon, that's the one I prefer right now to send people to. But if you this one takes you to the Manning website, and that one you can get 50% off. So if you want 50% off, use this coupon code at the Manning site. Um, it's come to my attention that a lot of people don't like Amazon, so I'm putting up the other link. All right, that's enough shilling. Let's get on with it. So domain modeling is a kind of software design, and software design is not easy. It's like this multi-dimensional search through, or it's a search through a multi-dimensional space. You got all these choices to make, and not only do you have to make uh, a lot of choices, the choices affect each other. So if you make a choice, to like use a hash map, well, that means it's going to change something over here that now you have to make a different choice. And so it's really hard. It's just a really hard problem. Uh, so I have this hypothesis that because you have to make all these decisions, really what you're trying to do is get good information. And the source of that information is the domain. That's what domain modeling is. It's just looking to the domain to help you make the right programming decisions. Um, I'm I'm trying to define software design as broadly as possible. A lot of software design texts are talking about like code quality or some kind of ephemeral aesthetic that you find in the code. And I really want to talk about everything from the algorithms you choose to how you structure your application, to if you use a for loop or a while loop, all these choices that you make, that's all software design. So this is this graphic. I'm trying to illustrate what the lenses are. Like each lens is giving you this little peek at one aspect of a whole. There's a whole out there. There is a whole design that you're trying to get a peek at. And I can only show you a little bit at a time because it's too multidimensional. You can't see it all at once. But hopefully, if you get enough lenses, enough peeks at it, you can kind of get the whole picture. That's the idea. The main um, sort of vision behind what I'm trying to teach is that you will wind up with a library that is very expressive for your particular domain. And it's so expressive that you can say anything you need to say, any scenario you can come up with in your domain, you can easily write out an expression that will represent that, that will encode that scenario. And if you have a good, if you have that good library, you're not going to have to code around it and all have all these corner cases that you're handling with if statements or what have you, all the other code that you have to write to handle the bad model. And so, sort of this is another hypothesis that a lot of what people call bad code or messy code is just they have a bad domain model that doesn't properly encode the abstractions that they need. And so the best way, you shouldn't just like refactor it. You should actually like try to find a good domain model. All right, so these are the lenses that I've got for my book. Did I mention I'm writing another book, and these are the lenses that I'm working on. I put them side by side like this because the ones on the left are actually um, sort of building blocks for like how to build a a domain model, and the ones on the right are like concerns that are like external concerns. That might not be the right way to put it, but it's something about, these aren't like these aren't things to build up a domain model, but they're things that you have to think about while you're building a domain model. So these are all of them. So I gave uh, a talk. This was end of 2023 that had these three lenses. So if you want, I'm not going to go over these other lenses. So you should find that talk and um, and watch those. This one is the one I gave 1 year ago here at the Houston Functional Programming Group, and um, these are the lenses I talked about, these four. And so there's only a few left. Well, there's actually only two left, time and domain. But I also have a much better, I have more things to say about runnable specifications. So I'm throwing in a half a lens there. All right, so let's get into it. This is just like to explain all the examples I'm using are from a coffee shop, and it's a Starbucks style coffee shop, which has three sizes of coffee, three kinds of roasts, and then a bunch of things you can ropes. And here's a JSON version of the this coffee. And we'll see some more of this stuff. I just want to give you a flavor for the kind of stuff that uh, we're going to talk about. All right, so runnable specifications as a lens, what does this mean? So I mentioned before, the main vision behind runnable specifications is this super expressive library that captures the important concepts, behaviors, rules, data that you have in your domain. And if you have such a library in your in code, um, you you can easily express any scenario you need to express, and that will help to enter your application, enter that portion of the application. Any application is going to have multiple domains. And the tools that I'm giving in the book is that you do everything in code and it will lead you to this library. Um, you don't model it in an external form like in UML and then have to translate it. You start in code and you end up in code. And so you're constantly moving toward and refining this library that becomes it's like a good domain model. Here's a schematic of the domain modeling process. So the model, it kind of just exists in your head. It's just an abstraction. Uh, and there's the domain outside that may or may not be so clear what you're trying to model. And then you're trying to convert it all into code at the end. So you abstract stuff from the domain. That just means you're leaving out unnecessary details, things that don't matter to the business that you're running or what have you. And then you're going to encode it in code, right? Now, when it's in code, you can do stuff that's interesting, like even just looking at it, you might say, huh, that's not going to work. Or maybe you can't see that, but you run it and you say, well, it didn't work. And so then you can evaluate how does this code, actually encode the model? Like, does it do a good job? And maybe it does, maybe it doesn't. If it doesn't, you can encode it another way and you can go through this loop on the right until the code is good. But maybe you say, well, it kind of does what I thought it would. Well, like it's a good encoding, but it doesn't capture something. There's something missing that I need to go back to the domain and learn more about. Right? So there's these two loops going on where you're learning about the domain and you're also learning about how to encode your model. And your model is changing. Your model is how you understand your domain. And you're refining your model because you've got code, which is this formalized language for encoding your model. All right, I want to stop here and just ask, like, uh, what do y'all think of this? Any questions so far? I know it's all very abstract right now, but I will have concrete stuff in just a minute.
So, I'll jump in here and say, one, I think that this is a clearer explanation of this process than I've heard from you before. Because I think you and I might have had some conversation about this, or maybe you were on your podcast and I was just talking at your podcast about being confused about the domain versus the model and where they
Uh-huh,
were
uh-huh.
all located. Um, what I wanted to say, and I know we've talked about this before, is that the model that you're presenting here is so similar to in the model that I use for understanding social research and how we conduct social research.
Mm-hmm.
And I can send you a slide. This is in fact from the talk that I gave just last month that essentially is doing something so similar to what you're doing here. But
Wow.
yeah, what you're articulating here is very, very close to how I understand the process of social research being an interpretive process, basically, to come up
Got it.
with constructions of, so not constructions, social research is constructed, and what we're constructing are representations of social life.
Mm-hmm.
And what you're doing here is so similar to me, at least. So I think this is very interesting.
Cool.
Oh, so,
Cool.
um, I would like to interject there as well, Eric. Uh,
Yeah.
it's to introduce some software engineering lingo here, some terminology. I think what I understand from this slide and from your presentation is that the model would be in software engineering would be the requirements and then the specification of those requirements, like if you go to very regulated industries, you would want to every line of code would have to be associated with a spec, with a specification, and
Mm-hmm.
you would have to prove that that line of code, what part of the specification for the problem that you're solving is addressing. So I guess that's what you're trying to say, that the model is something that you maybe not only in your head, but you have as a written requirement, and further, more than a requirement, a specification for a requirement.
Mm-hmm.
Is that does that make sense? Is that
Y-
something that
y-
you can?
yes. Um, where do I start? So, yes, the model is your understanding of the requirements. Um, I've never worked in an industry that was quite so regulated that they could just give you a book that's like, here's everything that your software has to do. Um, when the jobs I've been on, there's rarely anybody who knows what it's supposed to do. They might have vague ideas. And so part of the modeling process, vague meaning they don't have a very clear model that could just be encoded right away. Um, you would need to go through this process of encoding it to realize how imprecise their understanding is. And so you might do this and then show them, right? Do you mean this way or this way? Because we need to resolve these ambiguities somehow, right? And one thing you can do when you do this like new look is to do kind of a scientific test, right? Where you say like, well, I've got this code and it has certain behavior. Let's test that the domain behaves and that it will get the same answer as the domain will get, right? Um, and if it doesn't, you got to re-abstract it and figure out again how to encode that new abstraction. Uh, and my understanding, like I said, I've never worked in this, but my understanding from the reading is that it's actually very rare that the spec is good enough um, to actually encode directly. You have to you have to go ask an expert who will disambiguate like the language in the spec because they're written in English, or at best they might have like a table of like inputs to outputs or something that you have to code. Um, yeah. So, but that is the idea that there is some idea of like requirements somewhere, and you need to come up with a way of representing that, of encoding that in software. And that's what this is about. I hope that answers your question.
Yeah, thank you very much. Yes.
So if I can jump in there very, very quickly, one of the things that I really like about OCaml, getting into the statically typed thing, is it separates out the signatures and the implementation. And one of the places where I end up using the signatures, and this was very surprising, I didn't expect this when I was using OCaml, when I started learning it however many years ago, is I use the signatures for the entire left half of your model, right? So it's a way of sort of articulating the model, thinking through the domain and all that without actually having to implement code,
Yeah.
but it can still be compiled, it can still be evaluated, and it'll
Right.
tell me when the types don't work. And then
Right.
I'm like, what is going on? And then I realize, oh, I don't understand what I thought I understood. Over and over again that happens. And it's lovely. It's absolutely
Yes.
wonderful.
What you're describing is what I call the operation lens, where you just work with function signatures. Even if your language requires, a body of your function, just work with the signatures. And the signatures are the name, the arguments, and the return type. And just play with those, because you'll realize, like, oh, I need a third argument to this function. Otherwise, I'll never be able to calculate, I'll never be able to construct the thing that it returns, right? So I need to add this other input to the function. And like just working at that level, it's very lightweight. You don't have to invest a lot of time, or certainly you don't have to, you won't have as much to throw away when you realize your design is wrong. um but it tells you a lot, and that's one of the tricks, or the I call it a trick. Let me continue in the slides, because I'm about to talk about this. The idea is you're trying to get to code, like a library that actually runs and works. And if you are writing function signatures, those are ready to be implemented at any time. You don't have to implement them, but to get to the library, you will. But you're taking steps toward code, but they're small steps, very cheap steps to take. Um, and so you get to iterate more on the design before you commit to implementation. All right. So this thing, I have something. It's not quite worked out yet, but I had that thing at the beginning about my thesis, which was you need better information to make better decisions, so that you can have better design, because design is all about decisions. Um, and this diagram has like four kind of steps in it that create these two loops. And I don't know where it fits into this, but there's like four things that the lenses are trying to give you. They're trying to give you better information. They're trying to help you see more options. So I see beginners stumble a lot where they're like, "Oh, I have to use a class for this." Like, no, you could use a function, or what about even just a hash map, or just an enum, or there's all these options that are available, and we often don't evaluate them. And I want to say that, just like a chess player, like a given chess player will do better evaluating more options per move. I think we would make better design decisions, and so do better software design by evaluating more options. But then you have all these options and you need to evaluate them better. That's another part of the chess metaphor. It's like you have to know that that move is better somehow. You have to be able to compare them. And so you have to evaluate them. And then we need iteration and feedback, which is the loops. Like you want to be able to get through these loops. Like the more iterations through the loops, the better design you'll have, all things being equal. All right.
So,
So,
so
yeah.
Eric, I think Tim wanted to say something
Oh,
about the
sorry.
diagram before you move on.
Yeah.
Yeah, thank you. I just really wanted to praise the way this diagram's laid out, because it makes it clear it's a not a linear process. It's not requirements, arrow, code.
Right.
It's a loop. In fact, it's two loops, and it looks like an infinity symbol with your mental model of the
That's right.
nexus.
It's never ending.
And I agree so hard on the fact that you are often not given all the requirements up front. Nobody knows what they are. And that,
Or they think they have them. Right.
yeah. But if you have close access to domain experts, then you
Mhm.
can lower the latency between the going
Right.
back through the left side loop.
That's right.
And
That's right.
that's how you get the right side loop to go faster too.
That's right. I mean, this fits very well into the agile, ideology, the agile ideas of fast iteration, working
The
with your
spirit of
customer,
agile,
the
not the
spirit, whatever you want to call it. Like, I
cycle.
want to avoid the,
Yeah.
you know, I don't know, stamp agile on it. But I also want to avoid people thinking that this is a big upfront design process. So I need to like kind of thread that needle, which is kind of hard. But no, it does fit into the agile idea of like talking to your customers, um, lots of small iterations. The thing is, it's a design, like a what do they call it? Um, it's not a it's not building features, right? It is like a design activity. So it's not like directly gonna get your feature out faster, the feature you're working on today. But in theory, it will help you get, if you have a good domain model, it will help you get the next feature out better, faster.
I feel
So
like this agrees a lot with domain driven design, just in
yeah,
spirit,
in spirit, it does in
leaving
spirit.
methodology out of it because that's always too
Yeah.
paint by paint
I
by
have
numbers
I
type of
think
thinking.
I think it got recorded, but I have a whole rant on software on domain driven design, um, in the last one I gave last year. Um, so I won't do it now, even though I'm tempted to. I'm just gonna move on. Please do keep stopping me for questions. Okay, so to get this double feedback loop thing going and to wind up with code in a library that gives you all those nice benefits I talked about. There's three parts to this. There's modeling and code, there's separating specification from implementation, and there's feedback. So modeling in code. Why what is modeling? Why do we do this? So like I looked up the term modeling. That means all sorts of stuff. You might think of like this kind of model, a fashion model. Like there's like the artist's model who kind of gives you an idea of like what you know the shading and how to the colors and stuff and what you should paint. There's the architect's model, which is sort of a lightweight way of testing out shapes and how things are laid out in a very cheap building material instead of building the whole thing. Then physicists model too. They'll talk about building models. Um, and then there's this one that maybe is closest to what we do, which is like accounting is a model of transactions. Yeah, it's an abstraction that, when I do a transaction, I'm giving somebody money, they give me a good. That's like a physical thing happening in the real world. I'm using, particular bills that I pay them, and the good is a specific thing. But when you put a transaction in the book, you just say like $100 debit, $100 credit in the other account. It's an abstraction. You're leaving out all these details. So the kind of modeling I'm talking about is actually these three. So the architect builds this model to learn. They have all these ideas about how it's going to work, and they want to make sure those ideas are true as as sure as possible about their truth before committing to like expensive building. And then a physicist is modeling to communicate. Like that, yes, they want to solve some problem in physics, but they're also like gonna publish a paper or something. So they gotta write it down in a way that someone else could understand it. And then the accountant is modeling to record data and relationships. So this thing at the end, this is like what our production systems have to do. They have to actually record that data and process it correctly and but this is what we're doing. We're modeling to learn so we understand it better. And then we have to communicate with our team and with the stakeholders about what it does. Um, so we're kind of doing all three of these levels at the same time. Okay, so when we model to learn, we do all this stuff like we're reducing the number of variables. We're trying to make the problem more constrained. So one technique you might want to do is like not use the real database because that's got a lot of problems you're gonna have to deal with. You'll deal with them later, but you just use an in-memory version of the data. You want to build as little as possible to answer your question. You want to know, hey, do these functions, or is there a way to express this situation at the coffee shop? Like, how can we how can we build a thing that could even express this? We don't, let's not worry about implementation yet, but just looking at the function signatures and like trying to create a little prototype. And then you can defer decisions that don't answer the question. You can just leave them out. You don't need to. You can just use a stub. And then this one I think is like super valuable. It's like answer the hard questions first. A lot of people do this thing where they're like, they create a class and the first thing they do is they add all these fields and then click in their IDE to generate the getters and the setters. And man, the getters and the setters, you can generate those at any time for basically free. Even if you have to type them out, they're so easy to write. It's the hard methods that you should write first because you don't even know if you've got the right fields yet. Like, why are you worried about the getters and setters? And the reason I'm so angry is because I do this too. I'm like, oh, let me just get all this easy stuff out of the way and then I'll do the hard stuff. And then you realize, oh no. Yeah, I need something else. I need this other thing, but I don't have that yet. Oh, where would I get that from? Oh, I need to thread this argument from all the way up here and like if I had just done that one first, I would have learned that right away and I wouldn't have had to change all the code that I wrote that was solving the easy stuff. So, there you go. Um, right. So, we're we have to communicate. Our code is made mostly to communicate with other people. I mean, and to the computer. That's super important. I'm not saying it's not important, but uh, we have to communicate to ourselves in the future, to other programmers. And so we need to be able to um, to like try it out. Like, does this work on the use cases we can think of? You can run your thing, you can visualize it. When it's in code, you can do a lot more than you can in like English sentences. Uh, right. I mean, I don't know what more to say about this one. I think it's pretty obvious. I guess the last thing, the testing one. Um, One of the cool things that I've noticed by doing this, I'm gonna put process in quotes, it's process, is that at the end you have this like in-memory version, like it's a stubbed out version, but it runs and it's correct. It gets the right answer. The behavior is right. This can be your test oracle that you can compare your actual implement production implementation. So even if like you don't know how to like unstub it and make it productionized, like you can still use it as a test oracle. Um, which that's very valuable. Okay, so here's this other thing, the separating implementation from specification. This is the thing that whenever I ask people who think deeply about like the the process of growing as a developer, as maturing. This is the thing that they say is really the thing that separates juniors from seniors. That a junior is just like, I just need to get it working. Like that's really hard all by itself. So I'm not gonna do all this, abstraction stuff. But a senior starts to think about how to separate out the specification from the implementation. Okay, so I've separated them out. Specification goes on the top, implementation goes on the bottom. So there's all these techniques that I'm developing in the book to help this. So, well, let's just give some examples, I guess. Um, I guess this is trying to compare the runnable specifications idea to other ways of modeling. You can model in natural language, you can model in UML diagrams, but then you have to do this hard translation step. It's error prone, and there's still information that you're not getting in the UML diagrams. Like it might be really hard to implement. You might not have it disambiguated enough. And so you still haven't answered a lot of questions until it's actually in code. Um, so while it's useful, it's like that architect's model. It's not really gonna get you all the way. You still have, you shouldn't leave like you shouldn't spend a year on your UML diagrams and think, okay, in 6 weeks we're gonna code this up. Like you got to leave a lot of time at the end to discover all that stuff and work through it. Whereas in runnable specifications, you're in code in your language, right? You're in Java or whatever, and you just take steps toward the implementation.
Can I just ask a
Yeah.
question?
Uh-huh.
So I really like this idea, and my question is
Okay,
though,
good. That's a
so
good question.
no. Here's the question. So most of the time I see English specifications and UML diagrams used is when dealing with like I'll say non-technical people,
Yeah.
people who aren't familiar
Right.
with you. It could be someone who knows JavaScript but doesn't know Clojure, right?
Okay.
For example, or my boss who's a mechanical engineer, but
Mm.
he doesn't code. So do you have any thoughts, or maybe are you going to get into this on how you can make your specification runnable to non-technical people? And one thought that I have is like when my boss will say like, hey, I want this different colors, I sort of taught him how to use the debugger window in
Chrome.
Chrome, right?
Yeah.
And so he can like change the CSS and he can do all that. But like, are there other techniques like that? I mean, is this something
Yeah.
that needs to be part of your workflow?
Definitely yes. So for background, UML is this really well-developed system of diagrams, and it's really got like a methodology behind it. It's not just like boxes and arrows. About um, first of all, working through as the architects, as the programmers, working through the the design of the system in a way that gives you an artifact to talk to the stakeholders about, right? Like, hey, here's a use case diagram. I think that's what it's called, or like a sequence diagram. This is what we're thinking is going to happen. Like, this guy's going to press these buttons, and then the software is going to go do a thing, and it's going to return an answer. Like you, you have a slide that you can show them so that they understand what you're going to program before you program it, right? And I think that that's like a very useful thing, right? Um, and the the thing that I'm worried about is that you do lose a lot of that sort of the casualness of it, right? Like, hey, we haven't thought that hard about it, but this is what you said, and like, is a little bit more formal than what you said. Can you tell us if it's right? Um, but there are ideas. I don't have them in this talk, so I'm not really, they're not like fresh in my mind, but there is stuff like you can if your code is good enough, you can show them, hey, this is a function, here are the inputs, and it's going to return a thing. Like, am I missing an input, right? But then there's also stuff like you could visualize it in code. Like you could take the the data of your, of your model and present it as some visual way because it's runnable. Like you can do that. And what I mean is like you get a graphics library and you like just make it um generate graphics that represent what's going on inside. Um, so those are the two things I've got off the top of my head.
No,
But
that's good. I just
it's
was
totally,
curious.
yeah, it's totally an important idea.
If I recall correctly, that was part of the idea of the cucumber/gherkin language stuff too, in
Mm,
various languages, where they're like, write your test in a form
that's
that,
English like, so
yeah,
that
that's in
like,
the
yeah.
I sort of like the idea though of having code like prove you wrong, right? So like you can write
Yeah.
stuff in Gherkin, but you can't execute it. And I really like this idea that you can take things like reductio ad absurdum and say like, look, no, this is the idea. I've implemented it. This is why it's not going to work, or this is why it's going to work. That
Hmm.
kind of approach.
Hmm.
I like
Hmm.
it, and I'm just kind of trying to think how to
Yeah. Yeah, yeah,
interact with
yeah.
the.
This is also one of those um difficult things where um I don't know if I've ever had to present to a stakeholder like, this is what your software is going to do. Like, if you tell us to write it, it's been much more of the like agile way where it's like, I don't think you know what you want, so I'm going to put a button and I'm going to see if you click it. Right? And you tell me if it does what you expect, and like if you need it to do something different, and we'll work from there. Um, and you try to make it so that you can write that button in like an hour, uh, as opposed to going through like a big cycle.
That makes sense. Yeah, I think writing the button in an hour is probably the best answer, right? You just get something
Yeah.
out there quick and
Right. And get them to look at it right
Yeah.
away too. That's
yeah,
the other
exactly.
thing.
That's the challenge.
Okay. So back to the slides. So this is what Claude was talking about, the type names and function signatures. You can do a lot of reasoning in the specification world just with type names and function signatures. In the implementation world, you're gonna have the type definition. So like when I say type names, like in the example that I'm using in the book, you can just say, this is gonna return a coffee. And I don't know how I'm gonna store that in memory. Like, is it a class? Is it like if it's closure, it might be a hash map. Is it just a struct? I don't know yet. I'm not, that's too implementation specific right now. I just need something. I'm calling it a coffee. And then these functions are going to take coffees and return coffees. And I don't need to know exactly how they're built. And then and I don't know how the functions are going to work yet either. But I know the types that they're taking as arguments, as inputs, and what they're going to return. So this is what it would look like. So you just have, this is like TypeScript, like cheating TypeScript. So you just have like these types called coffee add-in and add-in collection. And you say, well, I'm going to have some way, some function that can take a coffee and return me an add-in collection. So the add-ins are like, the hazelnut syrup and all the stuff you can add into the coffee. I know it needs to be a collection because you can have more than one. It's pretty easy. So I'm just going to call it add-in collection. I don't know how I'm going to store it yet. And same with add-in. I know I'm going to need to take a coffee and add an espresso to it and then get this modified coffee. And like I said, I don't know how I'm storing anything yet, but I can kind of see that these are things that satisfy my use cases. Like the, I know the barista is going to have to press buttons on that screen to get to generate one of these. And then when you get into the implementation, it's got a lot more detail. Like just frankly, there's a lot more surface area, a lot more that could go wrong in this. And then you've got all the trade-offs and consequences that you've got. Um, so you want to avoid this as long as possible. Another thing is this idea of denotational semantics versus operational semantics. These are terms that um, I've been learning about recently. In denotational semantics, it's this whole field of computer science that's kind of not very popular right now. But the idea is you define the behavior of a programming language in terms of the meaning of the expressions. So you'll have some like primitive expressions that you'll maybe specify the meaning just in English. And then everything else is like built out of those primitive expressions. And that's how you define your programming language. Likewise, there's operational semantics, which is more like a compiler, where you're saying this expression will compile into this kind of behavior, this bytecode, or some other thing that the behavior is defined. So it's more like meaning versus behavior. So if we can stay in this meaning world, we can do stuff like this. So this is a denotationally defined factorial function. You'll notice that it first of all, it's recursive. So it's defined in terms of itself. It's doing a little bit of math, but it's kind of at the same level of abstraction. It's just checking, is my argument 0 and I'll return 1. Otherwise, I do this expression. Whereas if you were to define it operationally, you might do a for loop, and there's just a lot of stuff that's like not about factorial anymore. Like it's just about how do I calculate it. Now you might like when I say this, like the term that comes to mind is declarative, right? But declarative is one of these things that like one person's declarative is another person's imperative. Like people say, oh, map and filter, those are declarative. And I'm like, oh no, that's so imperative. Like I know exactly how it works because I've written them before. So it's not exactly declarative. But so this is a better term, denotational. It's a better term because it just means you're defining a function in terms of the meaning of other things that are well defined, as opposed to this, which is like the behavior. Okay, so what this leads into is that we can separate out different kinds of implementations. And I don't have a good term for the bottom one, for function implementation besides implementation. But function definition, in the book, I'm trying to separate these out and say that a definition is where you define one domain operation in terms of other domain operations. So here's an example. We're defining how to calculate the price of a coffee. So just so we can see the signature, it takes a coffee and it returns a number, which is the price. And so this takes it gets the size of the coffee and it then calculates the price based on that size and it adds it to the price of all the add-ins. Okay, so notice, there's a plus in there because we're dealing with numbers, so it's kind of at the same abstraction level. But we're not defining it operationally. This is very much in terms of the meaning of other domain operations. Now, the definition of size might be really simple. Like if you actually, or the implementation, sorry, of size might be something like coffee.size, right? Like it could be super, super dumb. right? Like it doesn't do anything. But coffee.size encodes an implementation, right? It's because now we know something about the type, the structure of coffee. Whereas this function, we could just stub it out and leave it, or just leave it as a function signature. And so this is what an implementation of it would look like. We're getting the size price because, but we're encoding, see the coffee.size in there. And then coffee.addins is like, we're assuming that structure, but then because we're using this this for of, that means it's got to be a hash map. So like now we're talking about the implementation details in here. And so we much prefer this kind of function definition as opposed to this kind of function implementation. They both get the same answer, but this one is, there's much less commitment going on here. Besides being cleaner. Oh, there we go. I have all these things about what they assume. So this assumes the existence of 4 other functions, all in the domain. This one assumes 2 of those functions, but then also that the coffee.size is a thing, so it must be an object, that the add-ins are an object, and that there's this algorithm for calculating the price. It's not just this simple sum. Okay, trying to move fast because I think I'm running out of time. Frequent and rich feedback. Oh, so we have this model, right, of the process. You want to make, you want to have more feedback. You will make better decisions if you can test your encoding against reality. And because of this model that we've got here, when you test your code and see what it does, you're actually testing your models, like your understanding, and the domain. If you've got a faithful abstraction and a faithful encoding of that abstraction, testing your code is also testing all the way back to your domain. So just a few things like work in memory, you stub things out, don't use a database, don't hit an API, work iteratively. This means that you're going from less to more correct. I don't know. This was very enlightening to me that there's a difference between iterative and incremental. Incremental means you build a thing in pieces, and iterative means you build it more and more correct over time. I thought that was really useful, so I put that in here. Okay, this is moving on to another domain, so it's another lens. So it's a good point to stop to see if there's any questions.
One set of questions for you, kind of going back, Eric.
Yeah.
Do you consider specification as under that? Would a mathematical lens be part of that, or was that a different lens where, like, if kind of the given some kind of inputs, they map to some set of outputs, kind of like the domain and range of my inputs? Because you talk about it as types, but if it's not just like, hey, it's a coffee, like here's what I can do, and does it make sense for maybe some of your initial abstractions of in memory to be just like a hash map of, given these predefined values, I can return this result as a hash map as a dumb function that's memoized.
Oh, I see. Yeah, so like I think I see what you're saying. Like you're saying use a hash map as kind of a stub for a function. And anything you can do. So I should go back in the slides. So oh, that was too far. So when you've got this kind of thing, like you are going to have to eventually define all your functions or implement all your functions, or it won't run, right? You got this size function that you never implement. Like at some point, JavaScript is going to say, hey, like it's undefined. So you need to implement it some way. What this is trying to do is to minimize the number of functions that actually have an implementation. The other ones, you want to maximize the number that have a definition. So maximize the number that are defined in terms of other domain functions, and then have this small set of functions that say, okay, these are the ones that know how, how coffee is represented. And so then you can stub those out with um, something that approximates what it's supposed to do, and hopefully it's a perfect approximation. And the book goes into data modeling. Like, okay, a lot of the chapters are already online if you want to read them. I don't have time to go into all that. But just keep that in mind, like this idea that I could change if I have a bunch of functions like this, I could change whether coffee is implemented with a class or with a hash map or um, something, anything else, because I have not this particular definition does not rely on that. Now, this one size might have to rely on that. But then I only have to change size if I change my mind about how it's implemented. And so you could um, say visualize the coffee, maybe even create like a prototype of the the POS that the barista will use, all in memory, and they could test it out and say, yeah, this is ergonomic and it's going to work for us. And it, oh, but how do I remove a coffee or remove a soy after I add it? If I'm hit it by mistake, they're going to ask you all these questions, and that's useful feedback for what you might need to add to your model. Um, but you can do all that like by implementing as little as possible in this sense of the word implementation. So yeah, stub it out as however you need to. All right.
I just
Any
want
other
to throw out
questions?
there that I feel like if clean code had a do-over, they would say, yes, that's what we're trying to say. Is just that if you decompose things smaller, you get more of a specification than an implementation.
Huh. I don't know if I should be happy or sad that you compared this to clean code. Um,
I hesitated to do so because I know that's getting panned right now, and there's a lot of reasons why that is not a good
so
touchstone. But
without commenting on the
I just
book,
want to say I think you're crystallizing
okay,
something that
yes.
people have been grasping for.
I agree with that. I agree with that. I've been reading a lot of software design books to write this book, and the more I read, the more I realize that people are hinting at domain modeling, but they're talking about code. Like they're explicitly saying, "Hey, we need to, this code has this problem because like say, usually it's something like, "Oh, it's hard to change," or "It's hard to read." And then they'll say, well, so we need to introduce a new function here. And then they might say like, well, the reason we know this is a function that has like a good underlying idea is that it's easy to name. And you're like, wait, wait, wait. The whole thing about underlying idea, that's domain. That's the domain. You're like hinting at like we need to find these good domain concepts that are useful to model. But that's the meat. That's what I'm trying to like. We're talking so much about code and whether it's clean or easy to modify, easy to change, and we're missing the fact that the 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 domain has all that information. Like how um what do I need to represent? And what are the operations that we're going to have? Like that's all in the domain. And people are looking in the code and saying like, oh, I can extract this as a method and doesn't it look nice? And like, it's not about looking nice. It's not about your code. It's about the domain. Anyway, rant. It's like we're talking about, it's like if you were giving a writer advice and all you told them was style. Like you're choosing the wrong words, use fewer words. Like, you have all these style, your tone is wrong. You have all these style suggestions, but you never tell them like, oh, your character development sucks, or like your plot isn't interesting. Like that's that's the meat of the story, right? Like the style has to serve all of that other stuff. And as an industry, we're just talking about the style. Okay.
Can I make a comment on that real quick?
Yeah.
Because you just pressed my button
Nice.
of which is that every discussion I see of software architecture pretends that it doesn't matter what you're doing, like
Yeah.
your domain is. And that's just to me, after being so long in this business, that's just the craziest thing. It's like, how can you pick an architecture if you don't tell me what domain you're in? Like, you
Right.
can tell me if you're writing a real-time game or enterprise software. I mean, those are different things.
That's right. That's right. And that's this like bone picking I've been developing for I don't know how many years now. It's just so um hard to find software design material, books or blog posts or talks or whatever that actually goes into something like all these other choices. They just try to make it all about the code. Like, oh, the problem is you have too many classes. Like, how do you know you have too many? Maybe you have the right amount of classes for your domain. Like that should be like how like there should be an objective way to know. Does the domain require that many classes? And do you have the right number? Like that's what I'm trying to do in the book is like say there's some objective stuff. Like go look in the domain before you like judge whether your function needs to have more than 5 lines. So anyway, thank you for that.
That may be the key nugget from domain-driven design is to understand the domain first.
I agree. But then there's like 400 pages on some other stuff that I don't really.
I'll admit I didn't read the rest.
Yeah, I mean, I watch talks from the domain driven design conferences. And first of all, I think it's very surprising that there's such a following of this thing. And I have ideas about why. But um they're talking about stuff that I'm like, is this in the book? Like, how did you? I don't remember that. And I guess it feels like I don't want to say this on a recorded talk. We'll talk about that after. All right.
On a positive note, I think something that will sit well with you in reference to that infinity symbol and being able to go back and forth with the domain expert is a link to this classic from Prague, an article called Imaginate.
Oh, okay.
It
I'll
just
search
somehow
for it.
snapped into my head in reference to the way you're talking about it. It's really old, but if my memory serves, it's got the notion of this loop of going back and forth and like figuring out what the core data structure or representation of what the domain expert wants is and letting them interact with it.
Mm-hmm.
Uh,
I think there's a lot of value to this, and I think that this is what rings true to me in the domain-driven design book is when they sit down with like he's working on something like automotive parts, and he sits down with the automotive engineer and he's like, look, I can write this code and like, does this look right? Does this decomposition of the concept make sense to you? And then there's like this back and forth. And they're technical enough that they're used to reading math and so they can read the code and be like, no, you know, these three things don't add up to that. There's like this intermediate thing in between, and so he's like, oh, great. And he goes back and he codes that up. And the next day he shows them, and there's this fast iteration with the domain experts that that to me is the most valuable stuff. Um,
I mean, if nothing else, it really tries to break the notion that the people that want the software will tell you everything they need to tell you
yeah,
up front, like that, because they can't.
right.
And we can't know that there are problems with it until we try to implement it. And it's easier to implement it in small bits because then you can keep that part in your head.
And I think there's this other thing which I'm trying to express strongly in the book, which is that we as programmers, because we have to satisfy the compiler, we can be a sort of formalizing force. The domain expert has this deep intuition. They really understand the domain. You could give them a problem, they could solve it right away. But if you ask them to just like tell me all the rules, I'll write them down in code, like they can't do that. Um, and they might make, all these simplifying assumptions that you don't like understand or whatever. Like you can help them express this domain in a formal language that has to run. It has to type check, like whatever like systems you can set up to help formalize your code. Those will all help this process. And I believe that programmers like can be this like I don't know. I'm calling it like a force, but you're helping the business formalize the understanding of the domain. And it could be a competitive advantage if other companies haven't done this. Other companies might be thinking in terms of features like, oh, we need a button that launches the missile, and we need a button that, adds a wheel to the car. And you're like, how does it even get put together? And you model it, and then you can make any UI that puts cars together, right? Okay. Thank you
One
for
other
listening
thing
to me.
about the infinity symbol that I didn't,
Well,
Yeah,
I
hold on.
forgot.
I do want to let Eric do his
the
final.
slides.
Yeah, because
So,
people are gonna start. We have more time
Fair enough.
after.
yeah, let's
Yeah.
do after. Yeah. All right. So the time lens. That was the runnable specification lens. This is the time lens. So the idea behind the time lens is, remember, this is like another perspective to take on your domain to extract information about it. Every sophisticated model includes at least one notion of time. So this notion of time could be something like the timestamp of when the thing happened. Or it could be something more sophisticated, like an order of, or sophisticated is the wrong word. Something more maybe subtle, like these things happened in this order, right? Maybe you don't know the exact wall clock time that they happened, but you know that this happened after that. That's a notion of time as well. And so you look at something like accounting, like we looked at before. Accounting actually has two notions of time. So there's this notion of time of the order of the transactions that happen. You can record the date of the transaction as well. But then there's well, okay, so wait, there's the date of the transaction. So that's when did this transaction occur? But there's also the notion of when did we learn about the transaction? So, like, if you talk to an accountant, like around tax time, and they're like, hey, did you make any purchases for your business that that you forgot about? And then you're like, oh, yeah, I did buy this back in November. They're like, oh, well, you didn't write it in the book. They're going to backdate that transaction. So they'll look at the receipt and say, oh, yeah, there it is. It actually goes in the tax year of last year, but I'm only writing it down today. Maybe it's February or March or whatever. Um, and so there's two notions of time in accounting. And every model, as it gets more sophisticated, starts to have some notion of time. And it might be because you need to be audited. I might have this in slides. Right. So there's different notions of time. There's the just calendar date time, there's the order, there's this as of time. So like what was the state of the account on December 31st? what was in there, what like in terms of money. Um, or you need to do a history with an audit. So like, how did it get to be the way it is now? We need to know if all those steps were legit. So the problem is when we build the naive models, we tend to just do update in place. We just throw away the past. We're all familiar with this. I don't think I have to dig into that, especially in a functional programming group. So in the book, I go over two models of history. One is the history of states, and the one is the history of mutations. So in the history of states, you basically keep track of the every state of the system. So here, this is just keeping track of one coffee. So this is time. So from left to right, time is going forward. This big arrow is the current coffee, the current encoding of the coffee. So you can see we started with this coffee and it was size mega and roast burnt, no add-ins. And then we changed the roast to charcoal, and then we added a soy, and then we added espresso. And so that's how we got here. Now, the cool thing is if you want to do undo, you just drop the last thing. You could keep it in another array to have a redo, right? But you just can move back in your, sequence or array of states, and that becomes the new state. And then if you need to move forward, like you need a redo, you just go forward, or you can redo. Instead of redoing, you can just work from there and add almond to the one you're at, right? And so that becomes your history. Like, how did I get here? And you're kind of going back and then forward in another direction, that kind of thing. There's the other one is history of mutations. This one's a little harder to implement, but we'll see it has some useful properties. Instead of recording the coffee and just keeping around all the old versions of the coffee, you have to encode in data the uh, some representation of the change. So this one is saying, okay, we're starting with this new default coffee, and then we're going to set the roast to charcoal. This is the same stuff. It's just shown differently as mutations. You're gonna add an add-in and then add another add-in. And so this is the current version of it. And I don't know if I have an animation to like go back. No. But if you went back, you would have to replay all of the stuff from the beginning to regenerate. So if you're on this one, this would be the current coffee. You have to replay everything up to there, and it would have that version of the coffee. Um, right. Okay. So we can compare these. The history of states is easiest to implement because you're already generating all those states. It's expensive to store in memory, probably not because you're sharing a lot of structure with the different states are sharing structure because you're not making a full deep copy each time. But it's expensive to store if you needed to like serialize it to disk or store it in a database because then you're not sharing anymore. You're serializing it to JSON or something, and now it's just bytes and you're splatting it all out into bytes. So the longer it is, the bigger it gets. So the history of mutations, it's harder to set up because you have all these functions that operate on your data representation, and now you have to convert them into data and then make an interpreter for that data that just calls the function that you already had, right? So it's not like hard, it's kind of mechanical. It's just like a big if statement to like wire up the data into the right functions. But it costs something, right? But it's cheaper to store because the data is smaller. It doesn't really grow as the size of the data grows. And it captures the intention. That's the thing that is the most useful about it. when we see this, we know what the intention was. The intention was to change the roast to charcoal. The intention was to add a soy shot. When you do this, you're gonna have to reconstruct the intention. You have to do some kind of diffing, and it's like never gonna be as data rich as this is. Okay. I'm going to get through this lens and then we can just have a big free-for-all discussion. Okay, the domain lens. When I talked about uh, this book and the ideas in the book is called Runnable Specifications, by the way. When I talked about it 3 years ago here, um, I made this mistake of teaching it as a process. I actually did have steps. And, I made all the caveats and I said, it's not really linear, but I'm going to do it linear just to teach it so that you understand. But really, there's a lot of loops going on. And still people were like, how do I let my manager let me do step number 2? And I was like it's done in your head. Like they can't tell you not to do it. I don't know. It was just, they were asking me process questions when it wasn't about process. And one of the things another mistake I made was I was saying this lens was called, or it wasn't lenses at that point, but this idea that became the domain lens. I was saying you have to look at the reality of coffee. And I can't remember who it was, doesn't matter. Someone said, because it's my fault, this is the way I explained it. Someone said, but in reality, you can't remove soy from a coffee because it's mixed in. Like you can't unmix it. And so I had to go into this whole thing, but it made me think, no, this needs to be its own lens because even though the way I explained it caused this person to misinterpret what what I intended to say. I do think that people jump to these kinds of conclusions, um, or not conclusions. They have these habits of modeling. So let's see some habits of modeling. So like let's say I ask this question to people. What is the problem we're trying to solve with coffees? Um, we might find someone who says, well, we're just trying to represent a coffee. Okay, that's kind of vague. Just represent a coffee. Someone else might say, well, we need to model how coffees behave. Someone might say, oh, raise your hand if like someone who might say something like this. This is maybe more interactive. Okay. Just kind of something vague, like, oh, we're just trying to represent coffee. Okay, what about this one? Model how coffees behave. Yeah. Okay. Anyone remember this from college? You have to turn the nouns into classes and the verbs into methods. Okay. And what about this one? You have to find the is-a and has-a relationships. Yes? Okay. So this one is vague. This is representing a coffee. It doesn't help. Um, this one is trying to capture this person who mistook what I was saying. Like you can't go from a coffee with soy to a coffee without soy. Um, so how can you remove soy from a coffee in your model, right? This one just to me is like crayons. It's like it's for it's for children. Maybe in university, like this, I remember this from university. It was one of the things they taught us. Maybe they knew that they were teaching us like finger painting, and that we would outgrow it, but I still remember it, and I still know people who are stuck there. And then this one is like the classic object-oriented design and analysis. We need to like have some kind of hierarchy of, a latte is a coffee and a coffee is a beverage and a coffee has a roast and a latte has a milk, like whatever. Like that's, um, it's it's just not what we're doing. It's not what we want to do when we model. But people have these sort of habits that they've developed over years, and they're going to jump to one of these modeling things. And so what I'm trying to do in this domain lens is to get them to like kind of see past their own habits and their biases. So one technique we have to look past that is to actually just look at the situation where there's this process that your software is part of. This is a coffee shop. There's a lot going on in a coffee shop, and there's like a computer that's like sitting on the cashier's desk that's doing something. Like, let's put it into context. What is it doing? So the customer walks into the coffee shop, gives their order to the barista. The barista punches it into the POS, and then the POS prints out a receipt for the other barista who's going to make the coffee. And also the POS is going to tell the barista like how much money it is, then the customer gives them the money and all that. Okay. So we're actually trying to like program this machine that's like right in the middle of this process. We're not modeling the coffee over here. Like this, he's got his own thing for how to make a coffee. We're not really interacting much with the customer. In this case, it's really the barista who is interfacing with the software, and then the the software has to print out a receipt or some, some kind of little paper that the barista is going to use to make the coffee. So it's kind of like this communication problem. Like the barista's tapping on a touch screen, and then it just has to communicate to this guy over here who's just making coffees. Um, so that's interesting to know, right? Like it's just about faithfully communicating to the barista. Now, the interface has to faithfully capture through the barista what this customer wants, right? So that's interesting too, because the customer might not know what they want. They might make a lot of mistakes, like, oh, I want a grande. No, actually, can I make it small? Like what? What is a grande? It sounds big, but it's actually the small. I don't know. So like they're changing their mind. The barista has to like keep up with them and all that. They might tell you out of order, whereas the barista, this guy, wants it in a certain order so that he knows how to make it the right way, right? So there's something else going on there that we have to capture. And then we also have to calculate the price. Now, if we keep digging and we go to the rest of the business, we might find that like, hey, there's this store manager who needs to look at all the orders like at the end of the week or at the end of the month and figure out like, are we going to need extra soy milk next month? Are we going to need more dark roast, whatever it is? And so they're doing some other work with this information. And then the guys in marketing are like, hey, did our promotion work when we sent out those coupons? Did more people buy, peppermint lattes than they did last month? So there's this other work that's going on too. And our software has to kind of do all these arrows here. That is that is where it fits in. So like mapping it out helps um helps see this that like we don't need to have a class that's the store manager. We just need to give the store manager some interface into the data, right? So like we're not doing this like find all the nouns, find all the faces and like make a class for each of them. But we have to like satisfy all of their needs with this software. And the more of those things we can put on the board at once. So if you had like a board because you're like tracking a serial killer, like you need to like put it all out there so you can see the patterns and stuff. And the more that you can put out there at once, the better decisions you'll be able to make. Okay, another question that can kind of clear our mind of our habits is how would you do it with pencil and paper? Like a lot of problems, like you would solve it pretty simply if you're just like, well, if I had to write down the order, I'd probably have like a pad of paper, and as they told me stuff, I would write it down, and then I'd pass it to the guy, and he would make it. And like, okay, that's kind of simple, actually. Like, can we use that as inspiration? Like, we don't need to like model the physics of coffee and how have some like infinitely flexible system. We just need to write down like three pieces of information: the size, the roast, and what add-ins do they want. Huh, okay, that's kind of nice. So this can kind of clear your mind too. We don't need to have a hierarchy of like a latte is a coffee and a coffee is a beverage. We don't need all that. Okay, the other one, this one, I don't know how to explain it, but you just zen out. You just sit there and you just stare into space and you're like, what is a coffee? And you're like, dude, whoa, what is a coffee, right? Um, Now we're actually modeling the order of a coffee. That's something that you might think about when you're zenning out. Like, what is that? I can only give this other example. I wish I had an example of you know, coffee orders, but like there's this guy, Connell Elliott, very inspirational to me. He has a whole design methodology called denotational design. And he gave this talk. It's like 2.5 hours. Wow, 3 hours of him explaining the process. And in it, he develops this kind of very simple because it's just, on slides, but it's like a graphics library. And he starts with this question: what is an image? And so he asks the audience, like, give me some ideas, even bad ideas. I want them. And so people gave all these answers, like, it's a rectangular grid of RGBA values, right? That's probably what I would start with, because that's what I think of an image is like just excuse me, like a big array of pixels. Um, some people said, well, that's a pixelated version, like a discrete version. You might want vector graphics that are like infinitely scalable. So you have like shapes, like triangle and circle and rectangle. And then you kind of make a collection of those. And uh, some people said, well, it could just be like a program that draws, like you just drawing some in some graphics library. But what he came up with was this last one, which was from zenning out, what is an image? And it's just a mapping from 2D space to color. And so he had this function that's just like, oh, it takes a point and it returns a color. And at first it seems like, oh, that's got to be super inefficient to like represent an image as a function. You should do a rectangular grid because like you know how much memory it's going to take and whatever. But the more you think about it, I'm like, well, actually, this one can represent all three, right? There's something deeper about this. Like the rectangular grid cannot represent vector graphics because it's not scalable. Like once you have to zoom in, like your rectangular grid is useless. Like it's just gonna, it doesn't have any more information to zoom in for. So like these three are like mutually exclusive, but this one can do all three. Hmm. But then also there's all sorts of optimizations that I mean he claims that he gets by looking at this very like he's trying to start with the meaning, right? We're talking about denotational, like we talked about before. Like, what is the meaning of an image? And it's just this mapping from point to color. There's all sorts of optimizations that you can do that you couldn't do in these. Even though we kind of know like the behavior of these, he discovered a lot of those. So this is the kind of process you're doing, like, what is a coffee order? And really it's just a way of it's just a way of communicating to the barista what you want and a way of calculating a price so that you can charge money for it. That's like, this is kind of all it is. Okay. So if you want to see the chapters that are already done, there's about 250 pages already finished. You can go to this URL. You can see that there's 4 chapters left and an appendix where I'm going to put all the codes so you can see it all in one place. Oh, that's not centered. That's my newsletter. Get on the newsletter. It's weekly, and I talk about this stuff. Okay, done with the slides.
All right, thank you so much. This has been great. I can tell just watching people on Zoom, people are very excited. So I'm going to turn it over for question. I guess the first question I have is, how much time do you have, Eric?
I can go on. Yeah, I mean,
Okay.
as long as I have a voice, I guess I can keep talking.
Okay, so we will open it up for questions.
Should I stop sharing my screen or what do you
I
think?
would keep sharing it for right now because people might have questions right now that you want to go back.
That's right.
And
Yeah.
and then soon enough, yes, go
Makes
ahead.
sense.
Are
Yeah.
these recorded questions at this point?
These are recorded questions at this point, so be polite. Yeah.
Don't say anything you could get canceled for.
On your denotational, that's Zen out.
Uh-huh.
Another thing, because I've mentioned before we started recording, we're kind of our CEOs pushing this a lot for us to build when we're rebuilding a system. But it's kind of, what are the operations we can perform on it too, right?
Mm-hmm.
So it's like the point to color or whatever gives you a set of operations you can perform on that.
Right.
Because you have a coordinate, you have a mapping, so there's some coordinates that you could say, well, what if I wanted to, like the SIC book, what if I want to invert or mirror this image?
That's right. You can flip it just by like multiplying the X coordinate by -1, right? Yeah. Right.
So I
can
guess
make
that is another way of thinking about the denotational, right? Is what are my operations
Right.
that this thing makes available to me as part of my what the
That's
spec
right.
is.
That's right. By working in this meaning space. So just a function from point to color. I don't know how it's implemented. I don't know what it does. You can start to think, well, I know that like translation, I'm going to need to move, translate this around some point or whatever. You can make a new function or a higher order function that takes this function and transforms the argument to it, right? But it also takes a point and returns a color. So it is an image as well. And you can write that, you can define it already without even knowing how your image is implemented. And you're doing it in a denotational style, meaning it's all about meaning and, defining one thing in terms of the meaning of another. As opposed to, say, if you wanted to translate something in a rectangular grid of pixels, now it's like an algorithm, right? You're like, okay, I'm going to have to copy this pixel over here and loop through all the pixels and copy each one to its neighbor. Um, it's 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 not even almost possible to define it denotationally.
So,
Yeah, thank you, Proctor.
so Eric, if I could jump back to when you were talking about time,
Uh-huh.
because there's a couple of things that I've run into uh, that I think are related to this. One of them is, if you don't have a concept of time, it's hard to tell the difference between a correction and a change.
Right.
And the other thing is, sometimes you need to know that something is going to happen.
Right. The future.
The
Like
future
there's
matters.
yes, or like a hypothetical situation, or like some counterfactual. Yeah, what would happen if I did this? Like there's all these things that Man, I have a talk from I don't know how many years ago about this. 10 years ago now.
But some of this stuff is really important. Like if you're calculating, say, withholding tax for people in the US, they need to be able to tell you in advance when they're moving to a new state or a new taxing district.
Right.
And in I don't know, I guess I've just worked on enough systems where because they didn't really have an understanding of time, it made
Uh-huh.
things just way more complicated than it needed to be.
Right, right. So I should actually put these in this list here. This as of date is like this is all the past. But there's stuff like, well, what would my taxes like if I moved to be, what would they look like if I moved to Texas? Because there's much lower taxes there, right?
Right.
And so I haven't moved yet. It's a hypothetical, right? But I might want to know. And so I could calculate them in a state that I don't live in just to see. Or like, what if I considered, there's questions like, is this a business expense or not? Like, well, what would it look like if it was? What would it look like if it's not? Without committing to it. And I think, I think you're absolutely right. If you don't have this notion of time, which is kind of related to the, immutability, because you're capturing values at certain times. Um, eh, you can't answer these questions easily. They become like really hard to do. Um, another thing you said that I want to comment on is that there was you mentioned that it's hard to tell the difference between a correction and an actual change. So uh, in an online discussion, I saw someone say like you need immutable state because people can change their name, right? Like we have users and people can legally change their name. So like you need to have it needs to be mutable so that they can change it. And like it's exactly what you said. Like, look, legally changing your name is very different from the name getting input incorrectly and I'm just updating. I'm just
Right.
correcting my name in the system. Uh, because you don't want to forget the old name. All my old contracts are signed with the old name. So, like, I was called that before, and now my name is different. Like, it's a very different situation from, you spelled my name wrong. Um, and uh, so yeah, we need to capture that, and you don't want to forget the past. And so that's why you don't want mutability, is because mutability forgets the past. The models have to be immutable. I don't even talk about that. I just assume that you're going to make an immutable model. Maybe I need to bring this up. But thank you for that, John.
Where that gets even trickier though is the database, because we're farther behind on making that natural to only record the changes instead of mutating in place.
That's right.
I mean, if you have
right.
datomic, then it's natural, right? But
Right.
if you have Postgres, it's like, oh,
You have to do a lot of extra work to like record the history or just model it correctly, like model like I'm only adding rows, right? Append only, not going to
there are a
change the
lot
other
of
stuff.
formalisms that have been documented in the literature of like how to use a SQL database to only record.
Right. The problem is the SQL queries get to be really hard.
Yeah,
right?
it's awful.
Yeah.
And then add bitemporality, and that gets
right.
even harder. And I mean, actually, Datomic doesn't completely help us with that either.
Datomic doesn't have bitemporality.
But XTDB. So, but that would be a great thing to add to the slide about, that it has at least one notion of time. It's just that bitemporality has two always.
Right.
Yeah.
And there's some research that's I don't really understand bitemporality in a database, but there's some research that the XTTB guys were saying once you have 2 in your database, you can model n, right? You can model more than 2 somehow. I don't know how, but
I'd
you
be
can.
interested to understand what that's talking.
Yeah. They're like, that's all you need is 2. So I don't know how it works.
It's like a coordinate instead, because I thought it was just system time and as of. Like you might have something that gets recorded after the as of, and so you want to know that you didn't know it
Right.
within
So
a
like
certain
when,
system boundary, but it's actually supposed to be effective as of a certain date according to the business logic.
right.
You also have a as of in the future too. So
Oh, yeah, good point.
I know something is going to change. There's going to be a new law on the book that takes effect at this. If I have a coffee order, I know that my sales tax is this today. It will be that in the
Right.
future, and I can record that ahead of time and know I know it now, even though it's not effective yet. So as of can be both past and forward looking too, like an effective date.
I'm gonna add this now. I'm gonna add the future and counterfactuals. I once this is the other thing I wanted to say. I once was programming a mobile app, and I made my own router, and the router was all done with immutable data. And so to know what the title of the screen was, if you hit the back button, like you would just, hit the back button in the library, but it would just generate this is the data representation of that screen. You just read the title out of it. And so you could put the title in the button, like this is where you're going to go without actually going back is a counterfactual. If you went back, this is what you would get. So it does have useful practical things even in like GUI programming. Thank you for that question.
So I had a question about in the domain lens. I'm not sure I'm going to be able to articulate this very clearly because I've got a bunch of different ideas going on here. You went through this list of like, what domain modeling isn't,
Yeah.
and why it's sort of done so badly. And one of the things that I immediately thought about was, especially about like when like people are teaching domain modeling, it is like modeling like what is the coffee or what is the pizza and how many toppings can the pizza have or whatever, that type of thing. It's modeling the thing rather than the process.
Yep.
Right? The process of taking a coffee order.
Yep.
And that made me think about sort of 2 separate things, and I don't know if these are related or not. So one is that as you went through that, you were talking about the coffee order, but then also the idea, this is where you started doing the serial killer chart of, but it's also going to be connected to how much coffee do we have to order in the future and that type of thing. And so one question I had is, aren't those separate domains that are related in some way?
Yes.
Okay, and then and speak more about that, but I want to get my other question in before I forget it. Is you're also talking about time, and how do you say it? As any sophisticated model will include at least one notion of time. And then I'm thinking about like the process of ordering coffee is fundamentally temporal. And then I'm just wondering about, should our domains, if we're working in software, are they always processes? And yeah, I'll stop there if that made sense.
Yeah. Um, there's three things. I'm gonna try to keep track of them. So the first one you mentioned was this list here that's got the different like bad ways to model. Um, one of the things that I guess I just have an example that I use because it's humorous to me. But like if you are modeling a grocery store, people will say, oh, it's great because you're modeling the actual store like an object in memory, a class, an instance of an object of a class is actually representing a real world object, right? Isn't that intuitive? But I have never sent a buy message to a broccoli. I have bought many broccolis, but I have never sent it a buy message. And that, I'm trying to like just show how ridiculous it is to like think that this is some kind of, there's some one-to-one correspondence between objects in the world and the code that we're writing. Um, you're really building an information system. You're writing the software that checks someone, it rings them up, right? It like reads a barcode, it keeps track of all the items that scan past it, and then it calculates a sum of all the prices, and maybe it talks to the inventory and it like docks out, we need to buy broccoli. Um, and uh, that's what you're doing. There's a whole bunch of other stuff that's not modeled at all about walking around with a shopping cart and putting stuff in your cart. Like that's not in the software at all, and it doesn't need to be. Um, and like knocking on a cantaloupe, whatever you're doing in the supermarket, it's not captured, and it doesn't need to be captured in the model. Um, so the second thing you said was about uh it was about this sort of diagram here where the question was, are these separate models? Yes, they are. These are separate domains. The one domain is the price domain, right? Customer doesn't really care what this guy's doing. I mean, in terms of the software and what the receipt looks like. He wants to get his coffee that he ordered the right way. Um, and this guy doesn't care what this guy is doing. Like these are separate domains. The thing is that when you have these arrows, you're really thinking about information flows that this POS domain, which is about like kind of authoring a coffee order, right? Where you're making mistakes and you're 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 taking it in like random order from the customer, like, oh, they said the roast first and then the size, like uh and then they change their mind, and you got to do all that, right? But then once it's finalized, it becomes like this piece of immutable data that can go to this guy, right? And then but that also has to feed into his domain. And so maybe there's something in here that you have to capture that isn't relevant to him, but is relevant to him. So like there is some notion of like it's gotta the data has to come from here because that's where it gets into the system, right? And so yes, it's true. This guy has his own domain. He is not changing the orders. He's not saying, oh, they really ordered, you know, a macchiato, and so I gotta go in and change the order. That's this person's job. He's just looking at that data as like, for inventory management, let's say. And so, yes, these are all separate domains with separate operations, but they all have to come from the same like kind of original data model.
You kind of touched on it in your presentation. Are you gonna highlight it in the book that, well, we're not actually talking about coffee now. We realize, but through this, we're talking about coffee orders.
Coffee orders, yes.
Is that
and
something that's becoming first class in the book? Because as you were talking about it, I was thinking through that is, yeah, it makes sense. You first think we're coffee, but where we're at part of your going back and you're looking back at it through your inquiry side is like, wait, this isn't coffees, this is orders, because we want to look at
right.
how many
We're
orders
not
were
modeling the
captured,
broccoli.
or like how
This-
many, because we're asking those questions, right? You said how many, what kind of ingredients do I need to
yeah,
project based off past orders, and how many orders are in a month or things like that, right?
that's right. No,
So,
I
so,
do
so-
talk about that. Yeah.
Okay, and I can't remember if you've talked about this or maybe you haven't, I've missed it. What you're suggesting now, and what I'm getting from Proctor is, okay, so you define the coffee order domain. These other domains, you're trying to map the relationships between them. And what I'm thinking about right now in this example, I don't know if this generalizes, is what other domains sort of have a claim on the coffee order domain.
Hmm.
And that might be a useful way for me to think about how these domains interact, because otherwise it can easily get into, well, all of these other things that are going on, and I'm pointing at the screen like you can see what I'm pointing at, they all get shoved into that domain, right? And what we're trying to do is separate those out and clearly distinguish the domains. This makes me think about like a relational database. And I do a lot of database stuff, but like, you know, references from one table to another,
Right.
and that they have claims on each other. And that's what, when you get into like cascading deletes and all these dependencies
Oh,
and that type
yeah,
of thing.
yeah.
And it seems like these different domains, they are linked in some way.
Right. And so this is a maybe a more just philosophical discussion. But like I know in the domain-driven design community, they have this idea of a bounded context, which is it's a very hard to define thing, but it's basically that the accountant or the store manager, when they're talking about order, they're not talking about it in the same way as this guy is talking about it, and this guy is not talking about it the same way either. And so yeah, they're all using the word order, but they mean different things, which is this is too vague for me. Like I want them to say like they are subdomains, or they're different domains that happen to, feed off of the same initial input, right? Um, and and by domains, they're going to have their own model, their own rules, their own operations, different scenarios that they're interested in, like use cases. And I think that what's interesting about the bounded context idea is that it helps people when they're modeling to like say we don't need the user class to have every single possible operation for all of these different domains, right? Like we can have a user class that's just for this guy, and a user class for the accountant, and like, and but it's all the same person in the real world that they're talking about. But uh it lets you simplify and by having different classes, that they don't all have to play nice. And it might be hard to formalize it if it's got all these different things. And it's easier to formalize just the price domain, and then you formalize the coffee printing domain or whatever. So yeah.
To troll the ML folks, that's Clojure's namespace keys and the speculation talk, right? essentially, like, I don't need to describe,
namespaced keys. Yeah.
like, I don't need to describe everything. I can just say, hey, it's got all these keys, and in this context, it's got these keys for this.
Right, but it might
Because
there
it's an open record kind of thing, and if you want to throw some other stuff into this record, it's still the same record. You might not care
sure.
about those keys.
Right. I'm not going that much into implementation.
Yeah, but conceptually in the closure world, that's part of the way we think
Right.
thought about in that case.
That's right. There's like an open world. Like there might be something that you don't know how to use that someone else does that they threw in there, and like you shouldn't blow up because they put it in there. Yeah. Right. So like I guess the concretely, like they don't have to have the same data. But the data has to come from this POS, right? Just by the way we mapped out this process. So like you might say, oh, we got to put something in the interface just to satisfy this guy, because it's got to translate or, travel from here to here. Even though, she doesn't really care about it. He doesn't really care about it. I don't know. Yeah. Now, another thing that the bounded context folks might say is that these guys get their own databases, right? This is where you would make a microservice for him and a microservice for him, and they store it the way they need to store it to query it, right? That they're getting events from, the POS and storing it their way. But in my book, the only thing I'm gonna say is like they're different domains, so they need different models.
I guess one comment on this thread, I noticed that you put an emphasis on how the data enters the system, and like the model was kind of couched in the data input. And maybe it might be influenced by who needs the ultimate output. But I guess I'm wondering if like that kind of generalizes, and maybe that's where you like start of when you're thinking through this process. I mean, I alluded to it's not a process, but
Yeah. Yeah, no, I know, I see what you're saying. That's an interesting way to frame it because I think the only reason I'm talking about that so much is because that's the example I chose to pick from the beginning because I feel like making a GUI is kind of like an interesting domain, right? Like it's visual, so you can put it in a book and people can understand it. And then it's going to have undo, so you have a notion of time. Yeah, but I think I should in the domain lens chapter I should talk about how there's really multiple domains going on here. You should model them separately.
Cool. And then no, this was great.
You had a
Thank you.
third question,
Yeah,
right?
right. Yeah, I was going to bring around to that.
I can't remember.
But so it was about if all sophisticated models include time, are all domains really processes?
Oh, right. That's an interesting question. I don't know. They could be. That you're actually, like an accounting system, it's like gathering information about over time as transactions happen. Is the coupon domain that this marketer is working on, is that like a process? I don't know.
I guess what that makes me think of is the pen and paper metaphor again of like this is ultimately an information system. And if software weren't part of the picture, some human would gather the data, transcribe it in paper, do something useful with it, and output it somehow. And I think we're ultimately automating those processes and making them more efficient when we build software for it. So I like to think that, yeah, processes is kind of like something we hone in on.
Yeah, maybe I'm the only one here old enough to have actually replaced a pen and paper process with it, but I used to do that. And I still think that's a really useful way of thinking about most business processes because almost everything can be done with pen and paper if you have enough pens and enough paper.
Right, and enough like secretaries to write it down.
Well, go look at the old pictures of the Social Security Administration when it was just started. It's rooms and rooms full of women sitting at desks with pen and paper.
Yeah, I imagine.
But on the other hand, there's at least one system I keep running into that I swear we haven't improved on pen and paper. And that's at the diner. When you go and make your order at an old-fashioned diner, I've gone to the places that have it all computerized, and they're never as efficient as the pen and paper.
No.
Now, I don't know why that is, but man, there's something to be said of if you're building solutions rather than software, sometimes there's no software involved in your solution.
That's right. That's right. It reminds me, I was doing a job interview, that's being interviewed, and the problem that I was asked to solve was that there was this pizza shop and the orders were getting like delivered to the wrong address and they weren't able to keep up with orders. And so the first question I asked was, how many pizzas do you make in a night? And they were like, oh, like 20 or 30. And I was like, you need to go to your kitchen and see what's happening. Like, do not write software for this problem. Just look around. It will be an obvious problem, right? 20 or 30 pizzas in one night. And that was the wrong answer. They were like, you're supposed to like tell me how to write a SQL statement that will create the model, the database model. And I was like, oh no, dude. And they're like, no, 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 but don't worry about that. And I was like, okay, well, if I can do anything, because like this is already going to cost you hundreds of thousands of dollars to develop this software for your 30 pizzas a night. Um, if I can do anything, well then like put a barcode on every pizza and like have a camera that's or a barcode scanner and like tracking how the pizza is going through the process. And they were like, whoa, that's awesome. It's like, oh man. I I didn't take the job, obviously.
I love those interviews where you realize, like, from the questions, like, this is not the place for me.
That's right. Yeah. I really felt like they could not that whoever was interviewing me right then and there was not able to really um judge like what a senior developer can actually do for a company, right? Like I can tell you not to write the software. Like that's useful. Okay, sorry about that. I'm glad I didn't say any names. Um, any other questions?
Well, especially since we're still recording.
Yeah.
So any last questions for while we're recording or comments or anything, and then we'll turn it off and then we can say names and be obnoxious and all of those things.
I just wanted to add on the infinity diagram. One of the things I've found that is really interesting about whether or not your model is going well is that if you take stuff from the domain experts and then you go through the cycle on the right where you've implemented some stuff and you see what it does, and then you start seeing that code implies things that the experts never told you. And you take that back to them and say, is this true? And they say yes. And then you're like, yes, okay, this model is becoming what it needs to be.
Right, it's predictive.
But if they say no, then you're like, okay, I need to.
Yeah.
So look for all the things that it implies that you were never said, and then go back and ask. It can be a little tedious. I definitely been known for. It's like, why are you asking all these questions? Because I'm trying to figure out if the model's right.
You're saying you might have to be annoying.
Yeah, but I think it's worth it. And it's a sure sign that your model is going in the right or wrong direction, depending on whether or not you're getting the yeses or nos.
Yeah. Yeah.
So
Sorry about the
that
music in the background.
that is also the argument for when you know that your scientific model is working, is progressive. That's a progressive research program that it can explain things that you didn't originally intend to explain, or it can explain things that occur in the future. So there is this parallel there versus a degenerating research program is one that essentially an anomaly occurs and then you have to sort of, explain why it's not really an anomaly.
After cycles or a smell.
Yeah.
Interesting.
Yeah.
Yeah. I mean, I look at this a lot like it's just the scientific method, right? You're building an abstraction about something happening in the world, and you need to refine it over time to make it right, and trying to formalize it.
So a corollary.
We just have this cool tool, the code, that I think, even I think scientists should use it more, because it forces it to be more formal.
All right, I am going to shut off the recording. Before I do, I just want to thank you, Eric, once again, because this was fantastic. And I think it's evident that we were all very excited by the talk and have lots of ideas and comments and all that. So thank you so much.
Yeah, you're welcome. Thank you. This is always great because it really helps me refine the ideas, not only because I have to sit down and make the slides and think about what I'm going to talk about. I really do use these as like notes for my chapters. But then all the discussion and everything, and seeing what interests people, and whether like the stuff I'm saying like resonates with them. Your group is great for that.